All right, let's dive into a really cool story about brains over brawn, but in the world of artificial intelligence. We're going to see how smart design, not just sheer power, can make all the difference.
So, let me ask you this. What if the secret to a better AI wasn't about building a bigger, more complex machine? What if it was more about teaching it good habits? A little discipline, right from the get-go?
Well, this is the story of our hero, the enhanced CNN-BN model. It's our smart underdog. Now, when we talk about AI size, we often talk about parameters. Think of them like little dials the AI tunes to learn. This little guy has just under 250,000 of them, which, believe me, makes it incredibly lean. So let's see what it can do.
Okay, so first things first, we need to really understand the challenge our AI is up against. What's the problem it's trying to solve? The fundamental issue is that if you just build a standard, basic AI to recognize images, it pretty much always hits a wall. It learns, sure, but it doesn't learn very well. So a typical baseline model struggles in three big ways. For starters, its training is super unstable. It learns slowly, kind of erratically. Then you've got this huge problem called overfitting. Basically, it just memorizes the training data instead of learning the actual concepts. So when it sees a new picture, it totally fumbles. And finally, all this means it hits an accuracy ceiling, getting stuck at around 71%. Not terrible, but, we can definitely do better. So to smash through that ceiling, our model gets a couple of really clever upgrades. And these aren't about adding more muscle. This is all about adding more discipline to the training process. The first upgrade is called Batch Normalization. Honestly, the best way to think about it is like a coach. Imagine an AI learning is like a bunch of players running a drill for the first time. It's chaos. Batch normalization is that coach who blows the whistle, gets everyone to start from the same ready position, and just keeps the whole thing running smoothly and efficiently. And the effect is, well, it's night and day. On the left, you see the old way, messy, slow, all over the place. But on the right, with that coach in place, the learning is smooth, it's stable, and it finds the right answer way, way faster. The second trick is progressive dropout. This is a brilliant way to fix that overfitting problem we were just talking about. Think of it like this. On a sports team, you don't want to just rely on one star player. So the coach rests the star player sometimes to force the rest of the team to get stronger. That's what dropout does. It randomly switches off some of the AI's star neurons, forcing the whole network to become more robust. And it's not just random, it's really strategic. In the early stages of learning, where the model is just figuring out simple shapes, the dropout rate is low. But as it gets deeper and starts to recognize more complex things, where it might just start memorizing, the rate goes up. We apply the most pressure right at the end to make sure it's really learning, not just cheating.
So, we've got a disciplined coach and a smart training strategy. Let's see what actually happens when we put this new and improved model to the test. This is the big question, right? Did all this cleverness, all this discipline instead of just raw power, did it actually pay off in the end?
Oh yeah, it absolutely did. This chart tells the entire story. See that dashed green line? That's our enhanced model's performance on images it's never seen before. Notice how it's not just higher, but it's way more stable. And even better, look at the tiny gap between the solid and dashed green lines. That's proof right there. Overfitting has been almost completely eliminated. And what does all of that add up to? This, a 5.2% jump in accuracy. That might not sound like a lot, but in the world of AI, that is a huge leap, taking it from just okay to genuinely pretty good. But, let's be real, no AI is perfect. And understanding where a model goes wrong is just as important as celebrating where it goes right. When you look closer, you see a really interesting pattern. The model is amazing at spotting vehicles. Cars, ships, trucks, no problem. But then you look at the animals, cat, deer, dog, and the accuracy takes a nosedive. Why? Well, because a lot of these animals look really similar to each other. I mean, to put a fine point on it, the model confused cats and dogs with each other 115 times. It's a classic AI problem, right? Those subtle little differences that are obvious to us can be incredibly tricky for a machine. Okay, so our model is good, not perfect. But its real superpower isn't just accuracy, it's efficiency. And this is where we see how our little underdog really stacks up against the giants of the AI world. Here it is, the classic David versus Goliath showdown. You've got ResNet 50, an absolute titan of the industry, with incredible accuracy and over 25 million parameters.
And then you have our model. Yeah, the accuracy is lower, but look at the parameters. Our model is over 100 times smaller. It's a fascinating trade-off between raw brute force power and incredible efficiency.
But wait, because this next comparison is the real jaw-dropper. MobileNet is a famous model that was specifically designed to be efficient, and our little underdog doesn't just match it, it crushes it. It's more accurate by almost 6%, and it does it with 18 times fewer parameters. It wins on accuracy and efficiency. That's amazing.
This chart just puts that size difference into crazy perspective. If our model's size is just one little block, then ResNet 50 is 107 of those blocks. And another famous giant, VGG 16, is a ridiculous 580 blocks. Our model is like a tiny, super efficient electric motor in a world of giant gas-guzzling engines.
So what's the big lesson here? What's the takeaway from all this? Why does having a small, smart model matter so much?
Well, the main thing is that in AI, best doesn't always mean biggest. A clever design, like we saw with those 2 upgrades, can absolutely outperform brute force. And this kind of efficiency is what lets us run powerful AI on our phones, not just in some giant data center. It all comes down to using the right tool for the job. You don't need a sledgehammer to hang a picture. And for learning, for quick experiments, and for tons of real-world applications, this smart underdog is absolutely the perfect tool. And that leaves us with a final thought to chew on. As AI gets woven into everything we do, from our cars to our coffee makers, where do you think these small, smart, and super efficient models are going to make the biggest splash? Because the future might not belong to the biggest AI, but to the smartest. Thanks for tuning in.